गुड मॉर्निंग स्टूडेंट्स। मैं बिंदु डडवाल, लेक्चरर केमिस्ट्री, गवर्नमेंट सीनियर सेकेंडरी स्कूल कल्याड़ा से हर घर पाठशाला में आपका स्वागत करती हूँ। आज हम करेंगे केमिकल काइनेटिक्स से कुछ और इम्पॉर्टेंट क्वेश्चंस। Why does the rate of reaction increase with rise in temperature? At higher temperatures, larger fraction of colliding molecules can cross the energy barrier, that is, the activation energy, which leads to faster rate. At temperature T1, the fraction of molecules capable of effective collisions is less. But at a higher temperature T2, the fraction of molecules which are capable of effective collision more than doubles, so the rate of reaction is also doubled. So rate is faster at higher temperature. On increasing temperature of the reacting system by 10 degrees, the rate of reaction almost doubles. The most appropriate reason for this is the fraction of molecules having energy equal to threshold energy or more increases. So option C is the correct answer. With the order given below. So hydrogen peroxide decomposition is a first order reaction, so 1B. 2NO plus Cl2 is a third order reaction, 2C. Ammonia at platinum surface decomposes is a zero order reaction, so 3A. And COCl2 gives CO plus Cl2 is a fractional order, 1.5, so 4E. Option A is the correct answer. Match the rate law expression with order given in column 2. So order will be the sum of the coefficients to which the concentration term is raised. So in first case, the order will be 3 by 2 plus 1 by 2 is equal to 2. So 1 is D. Then in second case, order is 1 plus 2. So 2 is 3. So 2 is C. In third case, it's 3 by 2 minus 1 is half. So third is B. And in fourth case, it's independent. So it's a zero order reaction. So fourth is A. So option C, 1D, 2C, 3B and 4A is the correct answer. Time required for 100% completion of a zero order reaction is, for a zero order reaction, T is equal to A naught minus A upon K. As A will be 0 because 100% has reacted. So 100 minus 0 upon K is not given amongst the option here. So option D is the correct answer. The overall order of reaction, which has the rate expression, rate is equal to K into A raised to power half into B raised to power 3 by 2 is half plus 3 by 2, which is half plus 1.5, that is 2. So the reaction is second order. Option B is the correct answer. Half-life period of a first order reaction is 100 seconds. Then the rate constant will be, so if T half is 100 seconds, the rate constant will be 0.693 upon 100. So according to the scientific notation, we have to put decimal after one digit. So this becomes 6.93 upon 1000, or 6.93 into 10 raised to power minus 3 seconds. So option A is the correct answer. For a reaction N2 plus 3H2 gives 2NH3, the rate of reaction with respect to NH3 will be plus 1 upon 2 change in concentration of NH3 with dt. That is option C is the correct option. This is because plus sign is to be put for because ammonia is a product, there is an increase in its concentration and we have to divide it with the stoichiometric coefficient 2 so that the answer in terms of all reactant and products comes out to be the same. An example of zero order reaction is option A, thermal decomposition of Hi on gold surface. Half-life period of a first order reaction is option D, independent of the initial concentration of reactants. Half-life is equal to 0.693 upon K and there is no mention of initial concentration in the equation. Which of the following graphs is correct for zero order reaction? So option A and option D are the graphs for zero order reaction. Match the units of rate constant column 1 with order of reaction column 2. So second inverse are units for first order reaction. So 1C. Molarity second inverse is the unit for zero order reaction. So 2, 0. Molarity inverse second inverse is for a second order reaction. So 3B and fourth should be D. So option 2 is the correct answer. Say true or false. The units of rate constant of a zero order reaction are same as the units of rate of a reaction. True. Both have the units moles per liter per second. For a particular reaction, rate constant is independent of concentration. True, because it has a constant value. In general, for nth order gaseous reaction, the units of rate constant are atmosphere n minus 1 second inverse. No, the units for rate constant are for gaseous atmosphere 1 minus n and second minus 1. This should be the units. The rate of a multi-step reaction is determined by the fastest. No, it is determined by the slowest step in the sequence, so it is false. For the second order reaction with respect to a reactant, rate becomes 8 times when its concentration is tripled. No, if concentration of a component is tripled, let it be 3x, then because it's a second order reaction, so 3 raised to power 2 is 9, so it should be 9 times. So this is false. This statement is false. Match the effect of changing concentration column 1 or rate of reaction column 2 for the reaction having rate law. Rate is equal to K into A raised to power 2 and B raised to power 1. So if we double A, the rate will become 4 times because 2A the square will be 4A square. So rate becomes 4 times. Doubling A and B, it will become 2A the square into 2B. So that is 4A square into 2 times B, that is 8. So reaction should become 8 times. Doubling B, it should become 2 times. Option D will be the option. And A is increased 3 times, then A square is 9 times. So option A should be the correct choice. So 1B, 2C, 3D and 4A, option A is the correct answer. Define rate of reaction and instantaneous rate. Rate of reaction is the change of concentration of any one of the reactants or products per unit time. Instantaneous rate of reaction may be defined as the rate of change of concentration of any one of the reactants or products at a particular instant of time. What is the difference between rate law expression and law of mass action? The rate law gives the experimentally observed dependence of rate on the concentration of reactants, and powers of concentration of reactants on in rate law expression may or may not be the same as coefficients of the balanced chemical equation. Law of mass action gives the rate expression on basis of stoichiometry of overall balanced equation of a reaction. For example, consider A moles of A react with B moles of B to form C moles of C and D moles of D. According to law of mass action, rate will be equal to K into A raised to power A into B raised to power B, where A and B are the stoichiometric coefficients appearing in the equation. But the rate law expression is rate is equal to K into A raised to power X into B raised to power Y, where X and Y are experimentally determined values and may or may not be the same as A and B. Which of the following graphs represents exothermic reaction? So for a graph to be exothermic, the energy of reactants should be greater than that of the product so that the extra energy is released in the form of heat. So option A is an exothermic reaction. B is an endothermic reaction because energy of products is greater than that of reactants. It will absorb energy. And C will neither release heat nor absorb heat. So answer is option 1 only. Show that time required for 99% completion is twice the time required for 90% completion of reaction. Time required for 99% of the reaction is 2.303 upon K log of 100 upon 100 minus 99, which is 1. So this is log 100, which the value for which is 2. So equation becomes T99 is equal to 2 into 2.303 upon K. But for 90% reaction, equation will be 2.303 upon K log of 100 upon 100 minus 90, which is 100 upon 10, which on cancelling out is log 10, which is 1. So equation becomes T90 is equal to 2.303 upon K. So dividing T99 by T90, we get 2 into 2.303 upon K divided by 2.303 upon K. These cancel out and answer left is 2. So T99 upon 90 is 2, or T99 is equal to 2 times T90. The rate constant for a first order reaction is 60-second inverse. How much time will it take to reduce the initial concentration of the reactant to its 1/16th value? Consider initial concentration A and final concentration 1/16 of A. So time will be, according to first order equation, 2.303 upon rate constant, which is given 60-second inverse log A upon 16. 16 comes up, A and A cancels out, and equation becomes T is equal to 2.303 upon 60 log 16. So 16 is 2 raised to power 4. So 4 log 2. So 4 into 0.3010 into 2.303 upon 60. This comes out to be 4.6 into 10 raised to power minus 2 seconds. This is the time. The half-life of radioactive decay of C14 is 5730 years. An archaeological artifact contained wood had only 80% of the C14 found in living trees. Estimate the age of the sample. From the question, we understand that the T half for this reaction is 5730 years. From this we can find out the rate constant K is equal to 0.693 upon 5730 years. So it will come out to be 1.209 into 10 raised to power minus 4 year inverse. Now applying the integrated rate equation for first order reaction, we get T, that is age of the sample, is equal to 2.303 upon K, which is 1.209 into 10 raised to power minus 4 log of original sample is 100, and at time t it was found 80% of C14 carbon was still there. So on solving this, 2 5s are 2 4s are 5 upon 4 is 1.25. We get T is equal to 2.303 upon 1.209 into 10 raised to power minus 4 into log of 1.25, because decimal is after 1, characteristic is 0, and 12. If we look up 12 under 5 in the log tables, we get the value 0.969. So solving these, the age of the sample comes out to be 1846 years. That is your answer. A reaction is first order in A and second order in B. Write the differential rate equation. How is the rate affected on increasing the concentration of B 3 times, and how is the rate affected when the concentration of both A and B are doubled? As the reaction is first order with respect to A and second order with respect to B, the rate equation will be, the differential equation will be rate is equal to rate constant into A raised to power first order and B raised to power second order, so B raised to power 2. So this is the differential equation. This is the answer to the first question. Second part, how is the rate affected on increasing the concentration of B 3 times? So if we increase the concentration of B 3 times, then concentration becomes 3B the whole square into A into K is equal to new rate 2. So rate 2 upon rate 1 will become equal to K into A into 3B square upon K into A into B square. So 3 square is 9. So we get 9K into A into B square upon K into A into B square. So this cancels out and rate 2 is upon rate 1 is equal to 9. So rate 2 is 9 times rate 1. So the rate becomes 9 times the rate. Third is, how is the rate affected when concentration of both A and B are doubled? So the new rate, let it be rate 3, will be K into concentration of A is doubled, so it is 2A raised to power 1, and B is doubled, so it is 2B raised to power 2 because it's second order. So on solving this, we get rate 3 is equal to K into 2 into A into 4 into B square. So 2 into 4 is 8. So rate 3 is equal to 8 times K into A into B square. Now this is rate 1. So the new rate becomes 8 times the initial rate. Answer is 8 times. The rate becomes 8 times. Draw graphs to show variation of T half, the half-life period, with initial concentration A naught for zero order and first order reactions. So the T half versus A naught graph for a zero order reaction shows that T half is directly proportional to initial concentration and graph is a straight line. Whereas for a first order reaction, the T half value, it shows that it is independent of the initial concentration and the graph is a horizontal line parallel to the x axis, a naught axis. So these are the two graphs for zero order and first order reactions. What are the factors on which rate of a reaction depend? Number one, concentration of the reactants. The rate of a reaction is directly proportional to the concentration of reactants. Number two, temperature of the system. In general, an increase in temperature increases the rate of almost all chemical reactions. Number three, nature of reactants and products. It has been seen that a chemical reaction involves breaking of old bonds and formation of new bonds, as different reactants have different bonds and products have different bonds, so the nature of reactant affects the rate of reaction. Presence of catalyst. It's generally seen that the presence of catalyst increases the rate of reaction. Surface area, larger surface area increases the rate of reaction, and exposure to radiation. In some cases, the rate of chemical reaction is considerably increased by the use of certain radiations. Calculate the order of reaction for which rate law expression is rate is equal to K into concentration of A raised to power 1 into concentration of B raised to power 2. So the order of reaction will be the sum of the stoichiometric coefficients as appearing in the rate law expression, that is 1 plus 2 is equal to 3. So order of reaction will be 3. Give two examples of a biomolecular reaction. The number of reacting species, molecules, atoms, or ions, which collide simultaneously to bring about a chemical reaction is called molecularity of a reaction. And if the reaction involves the collision of two species, then it is a biomolecular reaction. So examples of biomolecular reactions are dissociation of hydrogen iodide, in which 2HI dissociate to give H2 plus I2 is a biomolecular reaction. Similarly, combination of NO and O3 is a biomolecular reaction. NO plus O3 gives NO2 plus O2. Things to remember: derivation of equation for rate constant for first order reaction, derivation for rate constant of zero order reaction, to find half-life period for first order reaction, to find half-life period for zero order reaction, then units of rate constant for zero order reaction, first order reaction, second order reaction. Dear students, this is all in today's video. Practice the topics that we did today, solve numericals, keep watching and keep learning. Stay safe and healthy. Thanks for watching. Have a nice day. Bye-bye.